Hello everyone, my name is Surya and welcome back to my channel. In today's video, we will be discussing stateless versus stateful application, what they are, how they differ and why they are used. We will also explore the scenarios in which each is applicable and the challenges of persisting data in a pod and how stateful sets help address those challenges. To wrap it up, I will also show you a quick demo to make the concept clearer. If you are new here, don't forget to subscribe to the channel for more videos like this in the future. Let's get started. Imagine you are working as a cloud engineer and your company has an online shopping application that contains front-end, login service, shopping cart service, and MySQL database. And you deploy all of these on Amazon EKS using pods and deployments. Everything is working fine. And after few days, users started reporting that they are randomly getting out of login page and user shopping carts are getting resetted whenever a pod restart and order history is missing after a database pod is recreated. And also they reported like some services behave differently on different pods. And they started confusing why this is happening. Kubernetes is supposed to handle all this automatically, right? Before addressing this situation, let's understand the key issues that helps to understand the problem even better. The first key issue is persistence, which means that keeping data even after something restart or crashes. For example, imagine you have a shopping cart service running inside a pod created as a deployment. If something goes wrong and the pod restarts, all the data in the cart will be lost. This happens because the pod was deployed as a stateless deployment without persistent storage. On the other hand, if you run the shopping cart service in a stateful set and attach it to a persistent volume, the data will remain intact even if the pod restarts, which ensures that user's cart information is preserved. And the second key issue is pod identity. Every pod in Kubernetes gets a random name. Even if it is crashes, Kubernetes creates a new one with a different name and a new IP address. Some services like MySQL or Redis expect a fixed name or address to work correctly in the group of cluster. And the third key issue is storage consistency, which means that the data will be the same whenever you access it. Even if the pod is restarted or moved to a new node, the data will be the same. Let's get back to the initial problem. The issue here is the app team created the database as a deployment instead of stateful set. The best practice is for the front-end services, we use stateless deployment because they don't need to store or remember any data inside a pod. That's exactly what stateless means. For databases, we use stateful sets as they require data to be persist across pod restarts. That's the key differences. Let's understand the difference even better. As I mentioned earlier, for the stateless application, we don't need to store anything or remember any request. And when it comes to stateful, where it maintains data and remembers past state. And for the common examples for stateless applications are web servers, API gateway, and microservices that don't store any data. And the common example for stateful set is databases and message queues. When it comes to scaling, in stateless service, pods are interchangeable and there are no fixed names or IP needed. When it comes to stateful service, pods are created in defined order one by one. When it comes to pod identity, in stateless, it is not mandatory. When it comes to stateful set, it is essential to maintain the persistent volume claims. Let's start with the demo for the stateless application. I have this manifest file where I have the kind as deployment with the 3 replicas and then I'm using Nginx image. Let's apply this manifest file. As you can see, the deployment is created. Let's check the pod. You can see my 3 replicas are running fine. Let me scale up the deployment and see how the scaling happening. So I'm using kubectl scale, deployment and the deployment name and setting the replicas to 5. So the deployment is scaled. If you check the pods are scaling parallelly. You can see the status as container creating. So it is happening parallelly when you do scaling in the status application. So now what I'm doing is I'm getting the first pod and assigning it to a variable pod name. So I'm just reading the variable. As you can see, I got the first pod name. Now what I'm trying to do is I'm creating a file inside a pod. So let's create a file inside a pod and add some data test. So I'm creating test.txt file and adding a data test. Now let's go inside a pod. As you can see, the file is created. Let's read this file. You can see the data is there inside this file. So now let's restart this pod to check the persistent. So now what I'm trying to do is I have added a file now to the pod. I will restart this pod and check whether the data is persistent or not for the stateless application. So I'm deleting my pod. As you can see, the pod is deleted. Now I will go inside the container and get the file. As you can see, no such file or directory, which means the file is not stored if you create a pod as a deployment. And now let me show you a demo for stateful application. First I am creating a storage class of type EBS as my provisioner. As you can see, the storage class is created. Now I am creating a MongoDB database as a stateful set with 3 replicas. As you can see, the stateful set MongoDB is created. Now I am creating a service and you can see the service is created. Now I am checking the pods for MongoDB and few of them are running and few of them are in container creating state. As you can see, the pods are getting created. Let's wait until they are up and running. Now as you can see, all 3 pods are running. Now I am adding a dummy product details to the MongoDB pod. As you can see, the product details are successfully added. I am also creating user orders inside MongoDB pod. As you can see, the user orders are also created. Let's go inside a pod and get the product inside. You can see we got the required product details. Now let's get the order collection. As you can see, the order data is also retrieved successfully. Now I'm going to delete the pod to check whether the data persists. I run kubectl delete command and the pod is deleted. Let's watch with kubectl get pods -watch command to see how the pods are recreated. The new pod starts creating and it's not ready yet. Let's wait until it's ready. Now as you can see, the new pod is ready. Let's get the product details again. As you can see, the data is still available. Let's get the order details as well. As you can see, we are able to get the order details as well, which confirms that the data is persist when you create a pod as a stateful set and attach it to a volume in Kubernetes. I hope this video gives you a clear understanding of stateless versus stateful application and how pod behave in terms of scaling and data persistence and the key differences with a demo. Thanks for watching and see you in day 38.